This lesson is about data tables, and the learning target is I can organize and find data in a data table. Let's say we had a farmer. Maybe not quite a farmer, but maybe just a guy who wanted to grow some tomatoes this year. Ground was good. Tomatoes are nice to have around. So we'll call this guy John. And we'll give him a nice little straw. He's a happy guy, kind of happy. He wants to kind of grow his own food. But he's also a scientific guy. And so this guy, John, wants to figure out what type of tomato plant grows best. He wants to figure out if he should get cherry tomatoes or if he should get the slicer tomatoes. Now, he likes both of them the same. He just wants to know which plant gets bigger. And so what he does is he goes out and he grabs one little seedling of a cherry tomato, and he grabs one slicer tomato, and he plants them both in his garden. He waters them the same each day, makes sure they're in the sunlight. They're both getting plenty of that, and so all things being equal, he wants to see what the difference in height is between these two plants over time. And so he starts off, and on the first day, he's going to go out and measure the height of both the cherry tomato and the slicer tomato. And so he goes out, measures the height of the cherry tomato, and he sees that it is 5 centimeters high. And then he goes and he measures the slicer tomato, and he sees that it is 6 centimeters high. So starts off just a little bit ahead. Then he waits 1 week. Okay, so 7 days go by. He waters them the same every day, every other day, not giving them too much, and they grow just a little bit. And so he goes out, and on day 7, he measures the cherry tomato, and he sees, wow, this thing is 7 centimeters high. And he sees that the slicer tomato is also 7 centimeters high. So John keeps going, and he waits another 7 days. Gets to day 14 now. And he goes out, measures his cherry tomato, sees that it is now 9 centimeters high. And his slicer tomato is 8 centimeters high. Okay, so a little bit more time goes by. The plants get just a little bit bigger. And he goes out and he measures again. Day 21 now. And he sees that his cherry tomato is now 11 centimeters high. And he sees that the slicer tomato is 9 centimeters high. Another 7 days goes by, a little bit more growth on each of them. Maybe they're starting to branch out just a little bit more, but he's not really measuring how branched out they get. He is just measuring the height of the plants. And he goes out and he measures 1 month after he planted them, and he sees that the cherry tomato is now 13 centimeters high, and his slicer tomato is 10 centimeters high. And so John has created an experiment where he's controlled for the water amount, he's controlled for the amount of sunlight because he kept them in the same spot. They were getting the same amount of sunlight. He was watering them the same amount of water. And he was able to see how the type of tomato affected the growth of the tomato over time and how that changed as time went on week by week. And so what John did was he created a data table to hold all this information so that he could draw some conclusions from this. And there's some important things that we're going to look at with data tables that he's got to have in order to really have a good understanding of what his data says. So as we're looking at John's data table with this cherry tomato and the slicer tomato over time, there's some requirements that we should have with this. And as we make data tables in science, there's some things that we should have every time in our data tables to make sure that we have the information that we need to communicate to someone else our results and to really remember our results after our experiment. So the first thing that we always need to have is a title in our data table. So we should be talking about the variables that were changed or measured, the independent and dependent. We should be talking about, in this case, the cherry tomatoes in the slicer, or that this is a change over time and that we're measuring in centimeters and we're measuring the height. But some sort of title that describes the experiment that was done. The second requirement that we should have in a data table is talking about the variables. And when I say variables, I'm talking about what data is being collected. What are we measuring for? In John's case, he was measuring for the height of both of these plants. And he was changing the time, and that's what was going by. And so we should be talking about both the height and the time. Another variable that we had in here was whether it was a cherry tomato or a slicer tomato, and that's something that he was changing. But all those variables should be talked about in the data table. The third requirement that we should have for data tables is we should also have units. So for each of these variables, we're measuring them somehow. In John's data table, he was measuring the height by measuring in centimeters. Centimeters would be the unit for height. And he was measuring time by the day that went by. Okay, so that's how he was measuring that. And so making sure that we're stating how we're measuring our units is really important, because if he just said height, someone else could have thought that he said 5 meters or maybe 7 meters or 9 meters. Right? But it was very important that he was measuring in centimeters so that he could communicate his data to someone else who was interested in it. Maybe the next farmer down the road, or his neighbor who wanted some help with his tomato patch. And the guy thought that he was, growing his tomatoes by 2 meters every week. That'd be insane, right? So saying that it's centimeters is a really important part of this, and that's his units. So now that we have these requirements, we can take a look at his data table to make sure that it fits. So we're going to bring his data table back out here. And we're just going to go through it to make sure we have all these requirements. So let's look at the first one. If we looked at title. Does he have a title? He doesn't have a title right now, but if we're trying to figure out a title that would work really well for John's experiment here, we would want to say something that talks about what is he measuring, what is he changing, and what is this data table going to tell somebody. So let's say a good title for this would be cherry versus slicer tomato, height over time. It's going to give a good description of what our data table is going to tell. Our data table is telling what the difference is between cherry and slicer tomatoes in their height over time. So it's telling what we measured with both of those different variables, and also that we changed the type of tomato. So now let's take a look at the variables in his experiment. So he was measuring the time, and he was also measuring the height, and he was changing the type of tomato. So he has the type of tomato right here, which is good that he has that laid out. So I think that's really good. He has the time up here. He says it in terms of days, and I think the way that this is set up is fine as long as he's saying days, because that could be time, that tells time. If he wanted to, we could add time in here, but with something like days, it's going to be pretty obvious that that's what we're talking about, because that's a common thing for a lot of people, so probably don't need to say that. The one thing that I would add in here, he was measuring the height of these tomatoes, and so I would add in on the end here something about the height, saying that this is what is measured here in that data table, just so we know that we're measuring the height of the cherry tomato and the height of the slicer tomato. And then I'd say that's pretty good. We've got the time, we've got the height, and we've got the type of tomato in here. And then if we look at the units, we know how he's measuring time, and he's measuring time in days. So we're going to circle all the days. So he's circling days. We know how he's measuring time. This is really good. Lays out the number of days and how we're measuring it. And then if we look at height now, how are we measuring height? Now, he could put this in here, and some people do this in their data tables. You'll put it in with the variable and just put centimeters in this box, then you wouldn't have to have the labels in all of your data. And when you do that with a spreadsheet, which we're going to go over in the next video, you should do it that way, because you don't want to have numbers in your boxes. But he does lay out how this is measured every time, and it is perfectly fine to write this in the boxes every time. But if you want to save yourself some writing, you can put it in parentheses in the far left box that's going to label that whole variable. And so as we look at this table now, after a couple adjustments that we made, it's a pretty good data table. We've got a title. We're saying what variables we're measuring, the time and the height, as well as changing the type of tomato. And we're also saying how we are measuring those variables. So one of the learning targets for this video was to be able to actually pull information off of a data table. And so if we were looking at this data table, plant growth in soils with different pH values, you can see that we have our variables laid out here with the plant group. Not super important for this one. We're really looking at the pH and the average plant growth. So we can see, how does the pH affect the growth of a plant? We have a great title up here, plant growth in soils with different pH values. And then we have our units are also in here as well. So we can see that we measured in centimeters. pH doesn't have a unit, it's just pH, so it's just a number, and we don't have to add something in there. But we have all of those requirements for a data table. So if you're looking at this, what is the best pH for plants to grow? And go ahead and stop the video and try to answer that question looking at this data table. And as you try to answer that question, you should be looking down at the average plant growth down in this column here. You're looking at the numbers here of centimeters and trying to figure out which one is the highest. We look at 25, 33, 50, 53, 30. So we look at these two right here are actually the exact same. So what you could do, 6.6 or 6.8. Now, because there's a pretty consistent trend here where numbers are going up here and they look like they plateau at 6.6 to 6.8 and then they start to go back down, we could interpolate this data and we could say that, okay, well, these two are about the same. It looks like it was going up until then. It could be doing something like this on the way down. And so we could say that 6.7 was our best one. And I would also take that answer. That really depends on the data point. But you should be able to pull that data from there, seeing how the different variables line up in a data table, especially with this one with pH and the plant growth.